Greetings to everyone. Today I'm going to walk you through our project on market price prediction. Our aim is to develop a machine learning model to accurately forecast commodity prices, helping stakeholders make informed decisions. This is my third task as a data science intern in Mentorness. The data set given by the company is this, and the problem statement includes the data set we are using here includes data on various commodities across different markets recorded monthly. Key columns in a data set include market, month, year, quantity, price minimum, price max, and price mod, state, city, and date. A task involves several steps: data pre-processing, exploratory data analysis (EDA), feature engineering, model selection and training, model evaluation, and finally fine-tuning and validation. These are the important libraries imported. And the first process is data pre-processing. Our first step was to load and explore the data set. The three main steps here is collecting data and cleaning the data and handling missing values and other encoding variables. We check for missing values and fill them using forward fill method. We encoded here categorical variables using label encoding. The date column was converted to date time format and set as the index for time series analysis. And the second process is exploratory data analysis. We visualize the data to understand its distribution and relationships. This is the first graph. We plotted the price mod column over time to identify trends and patterns. This one. And the second, this graph is we decompose the time series data into trend, seasonal, and residual components to understand underlying patterns. And the next step includes feature engineering. To enhance a model's predictive power, we created new creatures, that is lagged variables. We added previous month's prices to capture temporal dependencies, rolling statistics. We calculated rolling means and standard deviations. Seasonal indicators, we added the month as a feature to capture seasonality. And the next step is model selection and training. This is the most important step. We split the data into training and testing sets and evaluated multiple models. We calculated ARIMA, SARMA, and linear regression. They have given in the problem statement to calculate using time forecasting models. So we used this ARMA and SARMA. We used ARMA because a basic autoregressive model that works well for time series data and is the best one. SARMA, an extension of ARMA that includes seasonal components, and we also calculated using linear regression used as a benchmark model. And the next step is model evaluation. In the model evaluation, we evaluated the models using key metrics, that is mean absolute error, mean square error, and root mean square error. And we have given the values here. These are the mean absolute error values, and these are the mean squared error values, and these are the root mean square error values for ARMA, SARMA, and linear regression. And the next step is fine-tuning and validation. To further refine our model, we performed a grid search cross-validation here. And the main steps involved in fine-tuning and validation are hyperparameter tuning, ensemble methods, and cross-validation. We evaluated different parameter combinations for ARMA and SARMA. This iterative process helped us identify the best parameters for the most accurate forecast. And the outcome, the ultimate goal of this project is to deploy a production-ready machine learning model that generates accurate forecasts for commodity prices and quantities. The insights derived from a model can help stakeholders optimize inventory management, pricing strategies, and resource allocation, thereby improving efficiency and profitability. And the last one is conclusion and the key takeaways, that is the future work. In conclusion, our project demonstrates the potential of machine learning in time series forecasting for market prices. Moving forward, we plan to integrate more advanced models like LSTM and implement real-time data processing and prediction capabilities, expand the model to include more commodities and markets. And this is the model I have created. We have imported the necessary libraries, loaded and explored the data set, and data pre-processing method, here the EDA method, and the feature engineering, model selection and training. These are ARMA and SARMA, and linear regression model, and the model of the values and the fine-tuning and validation for many values like of ARMA, SRMA. Yeah, this is the project I have created. Thank you so much for your attention. Thank you so much.